From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
And I thought, well, what do I know about it? I was like, I know about metallurgy. And I often see things where they're either not considering the materials aspect of things, or people often have wrong ideas about things. So I was like, all right, I'm going to start talking about some of these things on a regular basis and try to explain the science, the physics, the chemistry behind, there are reasons these things work a given way, right? We may not understand all the science, but there's certainly a lot that we do understand.
That was Sarah Jordan. Sarah is a metallurgical engineer and material scientist who is passionate about solving problems, process improvement, and process efficiency. She's worked in metal additive manufacturing since 2015. Sarah is currently focused on developing a new hybrid process called additive manufacturing evaporative casting at her company Skuld. The goal is a toolingless process that gives large precision, complex shapes, known properties, 100 times faster speeds, and a system that is 90% cheaper. They also have a couple other materials technologies they're working on to commercialize, including lightweighting and surface hardening. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcasts, including Spotify, Apple, Amazon, or Stitcher. All right, Sarah, thank you so much for joining us after I biffed the scheduling last week. But I'm excited for our conversation today, and I think we've got a lot of ground to cover. So I like to start out all of these conversations with just getting a sense of the person and kind of where you came from. So where'd you grow up? What was kind of your early story like before you kind of moved into additive manufacturing engineering?
Yeah. Well, thanks for having me here. I guess I was on your show a while ago talking about my prior employer, Fabrisonic, but yeah. So I grew up, I moved several times when I was little, and then when I was about 10, we moved to Southeast Ohio, Athens, which is a college town where Ohio University is. So I think that's what gave me kind of a different kind of background growing up in a college town than a lot of places, because even though it was small, there were a lot of, things that they do for the kids from the university, right? All these different programs for, art and engineering and things like that I think kind of foster creativity. And I think in the kind of meandering way, just help lead to where I am in additive now.
Awesome. And as you were kind of growing up and kind of thinking about kind of at least academic track, you want to kind of take us through some of those early decisions? Like, was there something that kind of particularly drew you to metallurgy, working with kind of building stuff? Was there any spark of inspiration?
Well, originally, I think when I was in high school, I'm also very interested in history and things like that. But there's also a practical side of it. My dad is a ceramics engineer, which is kind of under the materials engineering umbrella. So when I went to college, I didn't really know what I wanted to do, but that was something I was very familiar with. And I was like, well, that sounds interesting. I'd grown up visiting glass and ceramic factories, which I don't think is a normal thing. I can remember in high school going to visit how they make fiberglass insulation and just all kinds of things like that. So when I got to Ohio State, I was, I'll try this ceramic engineering thing. And I started doing that. And it was at the time, there was a materials engineering department, and they had three majors: materials, ceramics, and metallurgy. So I was in the ceramics. Actually, until I was the start of my senior year, I was actually originally going to be a ceramist, but I ended up changing because one, course scheduling, and then also all my work experience ended up being in metals. So I was like, this doesn't make sense to go try to graduate with no work experience when I've worked in foundries and steel mills. So I ended up changing over to the metal side.
And so one of the things that I think you're really awesome at, and we'll talk about this later in the conversation, is explaining kind of material science concepts. You have this awesome LinkedIn kind of snippet you do kind of weekly now on metallurgy. But for those who are listening who may not be familiar with some of the terms, like, can you kind of describe what does it mean to be a ceramics engineer? I mean, I know you didn't kind of focus on that ultimately, but kind of from a material science perspective, what do you mean when you say ceramics? What's kind of an easy way for people to remember that?
Yeah, so I guess ceramics is more focused on oxide materials. My dad always described it as inorganic non-metallic. They basically just defined it by what it was not. So it wasn't polymers and it wasn't metals, which isn't necessarily the best description, but it ends up being all these materials that are very complicated, whether it's like silica with its goes into like glass and all kinds of more complicated ceramics materials. There's kind of like the traditional ceramics, pottery, right? Goes back thousands of years. I don't know when glass got invented, but then there's like all kinds of modern things, right? Computer chips and things like that are based on ceramic systems. But yeah, thanks for bringing up my new thing, Metallurgy Monday, trying to explain that. I think partly because I see a lot of things that annoy me because they're like factually wrong. And it's clear that like a lot of people have no exposure to that. I guess the one thing that I kind of look at with whether it's ceramics or materials or metallurgy, a person tends to be very broad in the engineering fields, but then very deep in like that area. So we learn about, the mechanical aspects or the electrical aspects or what's happening chemically and all kinds of things like that. But it's all focused on a given type of system.
Yeah. It's so funny these days when like we go to these additive events and you're in a room and a lot of the technical talks, there's 5 or 10 other materials engineers in the space. Like it seems like there's such a density of people that are kind of coming from a materials background in working in additive now, but with kind of the work you're doing, kind of jump into the Metallurgy Mondays is like you almost take it for granted if you come from a materials background of like the nuances of some of the terminology, some of the conceptual understanding of like, what does it mean to be a metal and what are phase diagrams and all of this stuff that you study in school, but then as you get to apply it in everyday manufacturing, it's something that is certainly important, but to understand and apply, but then also how to communicate that effectively and what are the implications ultimately of okay, so what does it mean to have this as a phase diagram or other term?
Yeah, and I don't know what people learn at other universities. I know at Ohio State, almost all the engineers, at least at that time, had to take a 1 quarter long, so like 10-week, so maybe 30 classes, very introductory level materials class, but it was a very broad survey and they didn't really go into like any depth. So they'd be like, this is a stress strain curve. This is how you read them. And it was very, very basic. And I think a lot of engineers either they never even had that, or if they did, they don't remember or can connect the knots between, the designs that they're doing and things like that. So yeah, and I do agree that there are definitely often a lot of materials people, which has not been my experience in a lot of places. There are often none in the room.
And we'll dig into the Metallurgy Monday. So what was the idea? Like what was kind of the spark for that? And what's your aim with it? If people haven't checked it out, I mean, kind of follow you on LinkedIn and you've got these awesome kind of threads on different concepts. So you want to describe it a little bit more?
Yeah, pretty much just the idea. Well, somebody was putting out Manuscript Monday, which seemed like a good idea to kind of have some kind of regular cadence on a given topic. And I thought, well, what do I know about it? I was like, oh, I know about metallurgy. And I often see things where they're either not considering the materials aspect of things or people often have wrong ideas about things. So I was like, all right, I'm going to start talking about some of these things on a regular basis and try to explain the science, the physics, the chemistry behind, like, there are reasons these things work a given way, right? I mean, we may not understand all the science, but there's certainly a lot that we do understand. So just trying to break it down for, because it might be like half a page, right, that I type up. So it's not going into depth. It's very, either 101 level or even lower, like somebody who, they don't even necessarily have to be an engineer to understand like some of these basics. Although I found like I write about something and then it like people ask a question and now it like opens. I was like, oh, well, that could be like 5 other posts and these other questions, because it's like I recently did, oh, what's a phase? Well, that's because that's like a very basic thing that people in our field take for granted. But it's not actually easy to define in a, easy to understand way. We know it when we see it. But what does it really mean? And because somebody was like, well, what are these other terms like? But if you don't understand the definitions, it's very hard to understand any other parts of it.
For sure, and it makes it like the ability to go into detail on like, okay, how much, especially from an end user side or someone getting into the new technology, that you see all these hype stories about, hey, we could do this 10 times faster, or our parts are stronger and we can do it cheaper. And so having that grounding of material science, you can start to understand, okay, where's the marketing end and where does the science start, and what's that actual gradient look like?
Right. Like one, I don't know, I guess discussion I had gotten in was there are people saying that, powder bed stuff is 6061 aluminum. And I'm like, well, that's not true, because 6061 aluminum has to be wrought. Like that's the definition of that, like nomenclature, and something that's just welded together. Like, how is it wrought? I mean, it might be the chemistry, but I was like, that doesn't make sense to me.
And so kind of going back to your career story, kind of you're at Ohio State, kind of what was your first step after kind of the university? What did you want to kind of go into industry? Was that kind of your thinking at the time? Yeah,
after school, I ended up working in the Foundry industry. I spent some time at a startup Foundry as their CMM programmer, doing PPAP layouts, and I also did a bunch of work with quality. A lot of my background has been in quality, so I kind of started there in quality. They were working towards getting ISO. Well, actually, I think at the time it was QS 9000, something like that. This was like 20 years ago, whatever the numbers and systems were back then. So that's kind of what I started at. And then at some point, I decided to go back to grad school. I went to Ohio State, and I still wanted a project that was practical and very industry oriented. I was not so much into the super theoretical, although at this point I was kind of kicking myself, because so when I chose my project, I kind of had 2 that I was looking at. One was the one I did, which had to do with modeling steel solidification and fluid flow and things like that. And the one I didn't was actually related to the lens process. And that was like 20 years ago. No, more than that. Yeah, like about over 20 years ago. And I'm like, maybe that would have been a better, who knows where I would be though if I had gotten, done, master's or PhD in lens 20 years ago.
So you threw out some terms when you were describing kind of one of your first jobs on kind of the CMM side and PPAP. So for kind of those who aren't super familiar with the quality side, what does that mean on those acronyms? Yeah, so
CMM is a coordinate measuring machine. It's basically a device that kind of has a probe and knows where it is physically in space, so you can figure out all the dimensions and whether or not something is meeting the dimensional requirements, if it's the tolerances are wherever it's supposed to be. they're much more, at the time, the one we had was, modern for its time, but it was very it was very manual. Nowadays, they're basically robotic once you set it up. PPAP, it's an automotive term. What does it say? It's like pre-production approval process or something like that.
Yeah.
It's I might have got some.
I forget exactly what it means, but I know that when you see it.
Yeah, but it's basically doing all these things to prove out your process, that it's repeatable, and that you're giving the customer what the customer needs. It's, to me, very automotive focused. There are different kinds of processes and how they're kind of similar, but they're different if you're talking about aerospace.
Did you like working in kind of the manufacturing, the foundry setting?
Yeah, I like making things, I guess, at the end of the day. I've had jobs where it was more like a numbers type job, and I've definitely more of the hands-on. Even grad school, like the project I did do was very modeling and sitting in front of a computer all day, and that wasn't for me. I can appreciate people who do, finite element and CFD modeling, which CFD is computational fluid dynamics. So I appreciate those. I think they're important, but not for me.
Yeah. And when was your first introduction to additive manufacturing? When did you first see it?
Well, like I was exposed to it right when I decided not to do this project.
Yeah,
I saw this machine, and at the time I was like, wait, why would you blow up metal and then weld it back together? Like, that didn't make sense to me coming from like a foundry background. But and then I guess the second thing I remember seeing, and this must have been, I don't know, more than 10 years ago, maybe 15 years. There was a thing they sold on the Sky Mall catalog on airplanes. I don't even know if that's still a thing, but they had this pen where you could like 3D print in space from this polymer pen. And then even at the time,
right? The doodler, was that what was it called?
I don't know what it was called, but it was just like, what? Why would you want to three-dimensionally, right? Like by hand, like that didn't make sense to me. But then later I was like, eventually saw the ones where they were like kind of more like a CNC. I was like, oh, I get it. I can see how this is useful. But when the hand one, I was like, my hand's not good at drawing on paper. Yeah, so I'm not sure when I started seeing these more desktop hobbyist ones that came out, but yeah, maybe 8-10 years ago they started to become a little bit more now they're at like Micro Center for like $180 or something.
For sure. And so you finished your kind of graduate project. What was next on your career trajectory? Did you go right into, was it that kind of the next step to additive, or were there a few more steps?
Oh yeah. So after I got my master's degree at Ohio State, I went to Worcester Polytechnic Institute in Massachusetts. I was going to originally get a PhD there in surface metrology, but a couple of things. One, I wasn't super interested in what I was doing, and then my husband's job got moved to Indiana, so I ended up kind of putting that on hold at the time and stopping it. I'm actually back there now because my advisor's like, you're doing research, just finish the dissertation. So I'm kind of going back and finishing that with the work that I'm doing now, and it's a little bit related to surface metrology, but not so much. It's more focused on the additive things that we're doing now. And then after that, that's where at that point I went out to industry for a while.
Okay. And so you spent some time, I think we met when you were still at Fabrisonic. So that was kind of in that kind of the ultrasonic additive kind of metal fabrication. And what were you doing there? What was kind of your day-to-day kind of work like?
Yeah, so in some ways, my job at some point, I actually got an MBA. So as my husband said, I went over to the dark side, a little less focused on.
Is he an engineer as well?
He's also a metallurgist, exactly. So he's much more like technical, like deep, as opposed to like I'm more broad and over a lot of other different processes. But so after that MBA, I got into marketing a lot more. So at Fabrisonic, my role was, my title was product manager, and a lot of it was around trying to find what were the applicable market niches and the use cases for our technology. A lot of talking to customers, all kinds of things on that, and the things like they have a product that's really good with copper and aluminum. So there's a lot of like electrical type uses with electric vehicles. So a lot of my job was like, okay, in-depth understanding, say, the electric vehicle and the battery markets and things of that sort, to understand how to, position ourselves, communicate, their value proposition. And then a lot of that job was also, because they are doing R&D, trying to write proposals such as for the SBIR or other types of government funding mechanisms. So I also did a lot of that.
Okay, and you were super helpful in helping me do that for the first time. And so it was a good, awesome help in just seeing what people have done in industry on along those lines. We had never done it before. And I think again, I had saw one of your kind of LinkedIn posts that like, hey, like if anyone's interested in talking about SBIR, there's this America Makes event coming up, like come find me. And so I hunted you down at an MMX and we spoke for a little bit.
Yeah, I'm always happy to talk about people. There's these things called Zipper mills that they just exist almost to like do like these SBIR projects, and they don't necessarily commercialize it. And I'm definitely all about like, you want new blood, you want people who are going to do a project, but then it has some commercial intent. Like that's the point. So I think getting other people to understand that process is really important.
Mm-hmm. And so you spent a number of some good time there. Do you want to explain kind of what kind of your new company is and kind of what you're doing on that front? Yeah,
so I co-founded a startup called Skuld LLC, and we have, how do I want to say it? So there's some additive stuff that we're working on. I guess that's the focus of this podcast. So we are basically trying to merge 3D printing with a process called lost foam casting, which is a faster form of investment casting. I have actually worked at a prior startup related to lost foam casting, and then my business partner and I had co-founded a startup in that space actually in 2009, which was not a great time to have a metals company at all, let alone a startup. And that was the Great Recession. But we had developed some really good technology at that company, actually both of those prior companies. So Skuld kind of we're focused on this additive technology and further developing it, but we also have these other technologies that we're working to commercialize because they're farther along in the TRL level, right? Some of these processes aren't currently commercialized, but like we've sold commercial products in the past. So that's kind of like what Skuld's focused on. We had one SBIR related to our thin wall buckle iron technology, which is a lightweighting material. And then there's just a number of other things that we have going on.
And so what is it like kind of coming back to the kind of startup space? I mean, you had a company, you kind of did some of this work a number of years ago, both like not only from the technical side, but like you've had a number of years in between where you've been in industry, you've kind of seen what works, what doesn't. Like what have you learned this time around that you're kind of trying to apply in terms of running your own company, running a business, and kind of getting it off the ground?
Interesting question. So I guess I have two comments. One, having gone from like having my own startup and then back to like big Fortune 500 company, I kind of feel in some ways that makes it very difficult to deal with those kind of cultures, because you're used to a much faster pace where it's easier to make decisions. In some ways, I think having a startup or being in a startup kind of ruins you for those kinds of companies, because it was very hard for me to be patient and deal with the cultures at those kinds of companies. On the other hand, I also think that understanding how those companies work has also been very useful to what we're doing now. So I worked for 7 years at Emerson, which is a very large company. So I understand how their supply chain processes, purchasing, how their engineering systems work. And I think that is critical to being able to sell things to them that will help them. I don't know that every company works exactly like Emerson. I'm sure they're all got their own unique flavors. But I think if you're trying to, provide something to a really big company, that understanding how those companies are likely to be operating, kind of the bureaucracies that exist in them, how it's easy for one person to veto something because maybe there's 20 people that have to buy into something. I think that's been very helpful in this latest iteration of entrepreneurship, is to have that kind of background experience.
For sure. And would the idea for a lot of the products you're designing now in your systems and processes, would it be kind of a B2B type of sale that you'd be working on, or kind of that sort of business model where you have to directly apply that and say, okay, like this is a company I want to sell to, but here's the 5 layers of people that I need to convince before that gets done?
So it kind of depends, which I know is a metallurgy answer. I mean, so some of what we're working on are things that's like, okay, we're just going to make, say, a replacement part. And so then it's not necessarily, it's still likely to be B2B, but it could be B2C or B2G, like business to consumer or business to government as well, depending on, who needs a replacement part. So rapid replacements, I think, is one aspect of what we're looking at. So then it could just be all kinds of use cases. And this is very true for additive. It's true for like the additive loss film we're doing, as well as just like regular loss film technology. A lot of times you have to get these things redesigned to make the best use of the technology, right? Like you could just make a regular, say, casting and just convert like an existing casting to a loss film casting. You can do that. But it's going to cost more and you're not using the benefits of the process. So why would you do that? It's that when you're trying to change the design, well, that takes a whole lot more in these companies. And that's where we're generally trying to be. And I think that's where most of the additive folks are as well. And that those are definitely like, you're going up against big cultures that aren't designed to change rapidly. And it's often very challenging, I think, because of how those big companies are.
Yeah, Don Godfrey on the podcast a couple of weeks ago, and his comment was, I think he had read something in a Ford lunchroom or something that said, was it culture eats technology for breakfast? And certainly I've certainly seen that, and that like even now you get like some of these companies that have maybe tried additive once and like had a bad taste in their mouth. So like throwing out the buzzwords again to somebody to try and convince them to understand a new technology or kind of bring something in that they may have seen 5-10 years ago that wasn't ready. It's an uphill battle, certainly.
I've never heard that quote, but that's a great quote. Yeah, I mean, like, from my experience, what happens is if you're trying to get something redesigned, well, it's like you need a bunch of people to okay that, first of all. But then often no one owns a new thing. but people own the old thing, right? So if you're trying to, let's say you're trying to consolidate parts, each one of those parts has an engineering owner. Each one of those parts has a purchasing owner, right? And there's the new future redesign part has no owner sometimes. So it's like, you know, these 10 people can say no, but you don't necessarily have a person pushing it to get this redesign thing. And even if you do have somebody who's like, all right, they're appointed the new designs owner, like they're one person against this whole bunch of other people who can say no. And often they will say no because it's like, well, you're playing in their, you know, sandbox, and they don't necessarily want to give up one of their parts. And I mean, there's all kinds of these like reasons that things really happen. Like there's reasons people say things happen, but there's the reasons things really happen. It's because like people don't want to like lose control over what's their domain.
Sure. And the other thing that I've seen a lot too, especially recently, is this ability to, people will play along and say, oh yeah, I'm really interested in that technology. Like, let's test it and prove it out. But like, as you probably know more than me, with like, you can test and test and test and have new requirements and come up with these different types of quality assessments for parts that you can just extend that almost infinitely, right? Where again, it's just saying like, okay, no one's really willing to make a decision. We're just going to get more testing. And so like you get to a point where it's been a year and a half. You just done a million tensile bars or part geometries, and it's never enough for some people because they don't want to necessarily own the risk or own the ability for failure if it does happen, right?
Yeah, and I also think that's a good excuse if you really want to say no, but you don't want to come out and just be saying no. It's easy to just keep moving the goalposts, right? That, oh, well, you did well in those first 30 samples. Okay, well, now we're going to change what the requirement is, as opposed to being like upfront with what some of the things are. I mean, if you're upfront and you're like, look, you need to be in the MMPDS, you know, volume 2 handbook, and that's going to take, here's the list of tests. I mean, okay, maybe that is the requirement, then just be clear that that's what's going to take.
For sure. Yeah, it's certainly an interesting dynamic. And so like, how do you find what's your average day like now that you're doing a PhD, you're running a company? Like, how do you find time to sleep?
Well, the PhD is mainly doing things that I would already be, like the experiment part is stuff that I would be doing already. It's more like getting the discipline to do like the lit review and some of those, the paperwork side of things. So there, the key is just like blocking some time on my calendar every week. Like, all right, these, whatever, 4 hours are going to be working on that. I don't think there's a typical day when you have a startup or your own small company. I mean, you're responsible for everything, right? Whether it's the accounting side or HR issues or whatever. You know, talking to customers. So it's like all kinds of different things we have going on right now. So this main focus is this additive casting new process. We just got, so we've been doing all these tests, partnering with other existing foundries. So we'll do the mold part and then taking the molds to other people to pour for the trials. And we're actually in the process of installing a very large, well, medium large, I guess, aluminum furnace, 900 pounds. So that translates to about 2,700 pound iron or steel furnace. So it's good size. So we're installing that here. It arrived last week, so we'll be installing it over the course of the next month or so, which will allow us to make a lot of more R&D trials, and then also like I want to make a bunch of demonstration parts. I think it helps people understand what the process capabilities are.
And so what's I guess I have 2 questions for that. So first one is like, so you have kind of your own kind of warehouse lab space that you're doing all this work in?
Yeah, so we've moved several times in the course of the company. Where we are right now, yeah, we are partnering with there's a logistics company that we originally were just using their space as warehouse space, and now we're kind of taking a corner of their building for installing this equipment. I'm not sure how long we'll be in that space, but at least for what we're doing now, that's adequate. We actually own 3 induction furnaces, but the amount of power that those take is a lot. And it's actually like a very small number of locations that actually have sufficient electricity for us to be in, but eventually we hope to install those. But we need to have sufficient demand to, it's like a chicken and the egg thing, right? But we have to have enough demand to justify installing those furnaces in, because like there's peak power charges. It's like 10 grand if I turn those furnaces on, like the second I turn them on. So that's down the line.
How do you think about that in terms of, I mean, everyone's concerned about energy and sustainability now. Are there workarounds that you have to think about in terms of like, are we just going to operate at 3 a.m. so that we don't pay these crazy fees, or does that not matter as much? I mean, $10,000 is expensive, right? No matter what you're doing, but like,
yeah. So a lot of that depends on where you're just physically located. At least when we talk to the power places here in Ohio, they don't really give you a discount for melting at night. I think, things we're looking at is looking towards moving to places that do have, like hydropower and things like that. We'll see where it goes. I guess the way I look at it from, my own rationale is these processes are significantly greener than the alternatives.
Sure.
Because most metal at some point is cast, whether it's a forging or rock, bar stock, whatever. It's been melted and cast at some point, even if it then undergoes all kinds of additional process steps. I mean, even powder it's cast, right? It's molten at some point, and then they spray water into it to make it into powder. So in my opinion, going directly from casting to your finished component is like the most efficient way to make a part.
Right. Awesome. And so one other thing, kind of tangent, I've seen on your LinkedIn is you're also involved in Toastmasters. So I've always been curious, kind of what is that, and kind of how does it work, and what do you do for the organization?
Oh yeah, Toastmasters. So Toastmasters is a organization that helps improve public speaking. It could be like this kind of thing, dealing with an interview, or it could be getting up and giving a presentation. I definitely encourage engineers to get practice in that. I think most engineers tend to either be introverts or shy, or not necessarily the greatest public speakers. So I got involved in it when I worked at Emerson. They actually had a company club that met, I think they met every Wednesday. Maybe it was every other Wednesday. I can't remember. But so they have a whole system of how to practice public speaking and get feedback. It's very useful, I think, to get better at it just by repetition, practice. It eventually gets you over your fear of public speaking. I was the president of our club at least till the end of this month, and then I passed the baton on to somebody else. They're also very big on developing leadership skills. So they have rules that like you can only be the president for a year, and it's to encourage everybody to step up and to be an officer. Maybe you don't want to be the president, maybe you're just the secretary or the treasurer or something, but they're very big on developing leadership skills as well as speaking skills. I definitely encourage people to check it out.
And so what are some of the kind of the basics when it comes to that? Is it kind of, you have a platform, an opportunity for someone to listen to you and then give you feedback on it, or kind of do you also have like practice?
Yeah. So
drills or something. I don't know, that's probably the wrong word, but
yeah. So they have a couple things that they have this, well, it used to be a book, but that's now like online and a multimedia thing called Pathways that gives you training and tips and things to think about and practice. And then each meeting has a section where there are prepared speeches. So if you're doing your pathway, you'll periodically do one of these prepared speeches. And then there are people who are called evaluators. They give feedback on that speech. So they're kind of doing an impromptu speech in reaction to what you just said. And they might talk about, what your speech made them think about, but they might also be like, okay, you need to work on not saying all the time, or different tips of things that they notice. Maybe you just stand really rigid and, it's very clear that you're freaking out. I don't know. They'll give what they see as feedback. And then the other part of Toastmasters meeting, which when I first was exposed to it, I was like, oh, this is terrible. I'm never going to do this, is they have something called table topics. And table topics are totally unplanned things. There's somebody who's the table topics master, and they have something that's supposed to prompt, like as an impromptu speaking thing, where they give you some kind of prompt, and you're supposed to talk from 1 to 2 minutes on that prompt. And that's actually really good practice for a lot of things, like interviews like this, or job interviews, or things like that. And so it's definitely a good skill to practice impromptu speaking.
And is it nationwide? Is it kind of a nationwide thing?
It's global.
Okay.
They are like in, I don't know, like 150 countries or something like that. I mean, yeah, so they're not necessarily in every single place, but they're in a lot of places. And so I actually have to drive a little bit from where I currently live, but yeah, I guess check it out. They're definitely in a lot of places.
Very cool. So I guess last question for the day before we wrap up is we're kind of a little bit over midway through 2022. What are you excited about for the rest of the year? Is there you're doing a lot of work in a lot of different kind of aspects of your career, but what's on the radar?
Yeah, so I guess this additive process, continuing research in that, getting some talks and papers out on that, and hopefully some customers. Some other projects we're working on, we are supposed to be getting a additive-based process, actually related to a different kind of technology, from the SOCOM, the SoftWorks people. And then we're working on a current project. This isn't really related to the additive, it's related to casting side, where you're testing a new material for body armor. So I'm pretty excited about that. If it works out, it'll be, I think, a real improvement over current processing options. And, with everything going on in Ukraine, there's obviously a big need for that kind of thing, unfortunately.
And so if people want to find out more information about kind of what you're doing, what's the website, and will you be at kind of any upcoming trade shows, or kind of what's the best way to find out more if people are interested in your work?
Yeah, our website is skuldllc.com. So SKULD LLC.com. I'm also on LinkedIn, like you said. Yeah, I'm talking at the IMTS additive show here it's in September. I think it's in Chicago, but don't quote me on
backyard.
that.
Yeah.
I'm talking at that, and I guess that's the main thing. I think a lot of the additive shows have already, right? The big ones, AMEC, Rapid, kind of in the past, already have happened for this year. But I guess, yeah, come say hi to me at one of those if you're there too.
Fantastic. Well, Sarah, thank you so much for sharing your time today, and look forward to seeing you in Chicago in a few weeks here.
Yeah, thank you for having me. It's been great talking to you.